Yeah, hello all. I welcome you to another uh, video lecture in the series of this discrete mathematics paper discussion. And today I will going to discuss the graph theory part 2 lecture, in which I cover the rest of the things that I will continue from the last lecture. And in the last lecture we were uh, discussing about the bipartite graph, in which I said that a simple graph which is in which there are some vertices, and these vertices can be partitioned, right? Partition into two. Okay, partition into two parts like that, in which the set A and in set B there are connection between these two sets. And so when we actually talk about this uh, complete bipartite graph, so we have a difference between these two bipartite graphs, right? So let's see. Okay, I think it's have some problem with that. Okay, now it's fine. Yeah. So let me write a definition for this complete bipartite graph. So complete bipartite graph. Okay. So in complete bipartite graph, which is denoted as Km, comma m, right? And if you remember, the complete graph is represented by Kn, whereas complete bipartite graph is represented by Kmn. Okay, is the graph, right? The graph that has its vertices partition into two sets, right? Like we have seen in bipartite graph, right? In two sets V1 and V2. Okay, V1 and V2, and such that there is an edge between two vertices, right? So such that there is an edge between two vertices, right? So let's understand it by example. So first of all, what we have taken a set, right? Like, you don't need to draw this, like this is my way of representation. This I write this 1 2 3. This is V1 set. Okay, and V2 set, we have this set A, B and AB. Okay, AB are two sets. So okay, let's talk about these m or n numbers. So here V1, m represents the number of vertices in set V1, right? Where n is the number of vertices in set V2. Right? So m, here the value of m is 3. Here the value of m is. So the definition says that we have some vertices which are 5. Okay, 1, 2, 3 and AB. There are 5 vertices. You can number it 4, 5. Okay, whatever it is. And these are partitioned into two sets V1 and V2 like that, such that there is an edge between two vertices. So A1 is connected to A and A is connected to B. 2 is connected to A, 2 is connected to B, 3 is connected to A and 3 is connected to B. So this is your complete bipartite graph. Okay, and complete means all the edges are, all the vertices are connected to each other, right? सारे के सारे वर्टेक्स कनेक्टेड हैं एक दूसरे से, right? But it was not the case when I write the definition for complete for the bipartite graph. Here we have these two sets, right? V1 and V2. So 1 is connected to 2, but 1 is not connected to 4. Okay, so this edge is missing, right? This edge is missing. So if represent this, so this is the missing edge, right? Likewise, 3 is not connected to 6, right? 5 is not connected to B2. So if I add these 3 edges in this graph, it will become complete bipartite graph. So there is a difference between bipartite and complete bipartite graph, right? So here we have written this. Okay, sorry. So here is n is 2, right? N is 2. So we can see that if in the exams they ask you that in K3, 2 complete bipartite graph, what is the number of edges? So total number of edges will be your n cross n, right? So 3 cross 2, it will be 6. And total number of vertices is your vertices as n plus n, which is 3 plus 2, which is 5. Okay, right? So let me add another page, right? New page at the end, right? So right, okay. So in exams they are not going to ask about the draw this graph or draw that graph. No, what they are going to ask, that we have in questions, we have this complete bipartite graph in which we have 3, 4, okay, complete bipartite graph. So they are going to ask, this is vertices, how many number are the vertices, how many number of the edges, and draw this graph. They are not specify the name, means the complete bipartite graph, but when we have this type of representation in which we have m comma n in this form, so we will say this is complete bipartite, and we have this representation, this is complete graph. So do remember it, complete graph, and this is your complete bipartite graph, complete bipartite graph. Okay, so let's move ahead quickly because we don't have the time because of your exam, right? Okay, now we come to the graph representation, means how to represent the graph. Okay, so represent graphs. So there are two ways to represent the graphs. Okay, first is using your adjacency list, right? And second, the way is your adjacency matrices, right? Adjacency matrices. So in exams they will ask you questions about to represent a matrix into these two forms, right? So how to represent this, right? So let me take an example. Let's say that we have this graph, right? A, B, right? This graph, then we have C, right? We have some, okay, right? We have this. We have this type of graph, right? DE. It can be, okay. So how to represent these graphs, right? Using adjacency list. So let's take this number as 1, okay. So what we have to do, we have to do draw a adjacency list, right? This is your list in which we have two columns. We have vertex here, then we have this adjacent vertex, right? Adjacent vertex, right? Here we have to write the name of these vertex. So we have A, B, C, okay, let write C here, C, D and E, right? And then we have to write here the adjacent vertex to these vertices. So what are the adjacent vertex to A? So to A we have this B is adjacent to A, C is adjacent to A, and E is also adjacent. So for A we have 3 adjacent vertex. So what are these? They are B, C, E. This is your list representation of a graph. अगर किसी ग्राफ को पूछा जाए कि लिस्ट में आपको रिप्रेजेंट करना है तो हम ऐसे करेंगे. Let's take for B, है ना? For B we have one adjacent which is 1. For C we have A, E and D. So we'll write A, E and D. For D we have C and E. So for D we have C and E. For E we have A, C and D. A, C and D. So this is your list representation of a graph. So let's take another example. No? Let's take this graph A, B, C, and we have this D, right? So using adjacent vertex, right? Adjacent vertex. What we have to do, we have to sorry, adjacent, not adjacent vertex. The second representation is your adjacency matrix, right? Adjacency matrix, right? So in that we have to make a matrix in which we have this type of representation. We have this A, right? A, B, C, D. We have this A, B, C, D. The formula is, let's say in a matrix, you know, let's say if a matrix, if we represent matrix as A, okay, A is equal to A, I is A. Here I is A means I is rows and J is columns, right? Number of rows 4 is number of 4 columns, right? So the I and J is 4 because we have four vertices, right? So we have to write in this type of representation using matrix, right? So here what we have to do is, when Ai J is is, if I J is an as of G, right? G is graph, so we will write 1, right? So we will write 1, okay. So we will write 1. So we will write 1 when there is an as between I and J and 0 otherwise. Simple. So for example, between A to A, there is an as between A to A? No. So it will be 0. There is an as between A to B? A to B? Yes, we have an as between A to B, between A and B. So we will write 1 because of this definition. And there is an as between A to C? Yes, we have. This is the as. 2, we have an as between A and D? Yes, we have. So we will write 1 here. And for B, likewise we will do for B. So for B to A, we have an as. For B to B, we don't have. For B to C, we have an as. For B to D, we don't have because B to D is missing. Then say for C, let's take for C. C, there is an as between C to A and B. So we will write A to B. Okay, 1 1 here, otherwise 0 0. And for D, we have only one as between A to D. So we will write 1 here, right? Otherwise we will write 0. So this is your representation of, right, graph using adjacency matrix, right? So what if we have this loop? Okay, I change to this, right? If we have some loop, right? So what we will, right? Here we have to make some changes because there is an as between A to B. So we'll write 1 here. You got right? So it will be the case when we have this direction, right? We have this directed graph because it was the undirected graph. So we can represent the directed graph as well. So let's take an example for that. We have this, we have this, we have this, right? And we have this. Okay. So this is the undirected graph. So that matrix will be changed now because A to A, yes, it is going from A and terminus at A only. So A to A, yes, 1. A to B, yes. A to C is not because it is C to A. So A to C will be 0. Right? And then we have A to D, yes, we have A to D. So it's correct for this A. Then let's represent for B. So B, we have only B to C is because this is directed to, okay, you know, from B it is going, okay, and it is inwarding towards B. So the outgoing as is from B, right, which is only C. So at that we have only 1 here, otherwise for all the vertices we will write 0. For C we have only 1 outward, okay. So we have C to A, so we will write C to A 1, otherwise 0. So let me delete it, right, from here 1, otherwise 0, right. C to A, okay, C to A is 1, otherwise we will write 0. Okay, right. Then for D we don't have any as outgoing from D. Okay, so we will add 0 0 0 0 0. So this is the way you can represent, right, using the adjacency matrix, directed graph and undirected graph. And if there is a doubt, you can ask me. Okay. Now, okay, let's talk about another important topic, which is your isomorphism. Okay, which is your isomorphism. There are many questions. This has been asked in your exams, right? Uh, Isomorphism, or they have asked in your assignments also. So for the isomorphism, in simple terms, two graphs, na, G1 and G2. Okay, they can be G or H or whatever. So I'm taking this notation G1 G2. Okay, don't confuse with that. So two graphs G1 and G2 are isomorphic to each other if isomorphic to each other. The definition is in the book they have given a definition that the two graphs G and H or G1 G2 are isomorphic to each other if they are one to one and on to function. Okay, one and on to function. So it will be complicated to understand the one and on to sometimes in the two graphs if they are given. So what we have to find, I'm just giving a trick or simple solution for this, which is to each other when we have these three conditions for this. First, the number of edges. Okay, number of edges are same. Number of edges are same. Obviously in both the graphs, in both G1 and G2. Right. Second, number of vertex. Okay, your number of vertices are same, right? Are equal or same, whatever you say, in both G1 and G2, right? And number of degree. Okay, the degree. Okay, degree of vertices are same. Okay, in both G1 and G2. And the next which is are that adjacent vertices must have the same degree, right? Fourth is adjacent vertices are same. Adjacent vertices, right? Adjacent vertices of G1 and G2 are same. It must be same in both the graphs, right? So let's take an example for that. So we have this graphs. They have asked you in your exam that so that or identify or prove that these two graphs, okay, these two graphs are isomorphic to each other. These two graphs that I am just writing here, A, B, okay, okay, A, B, and C, E, and 1, 2, 3, 4, right? So if this is the case, it okay. Okay, 1 second. If I take another example, right? I take another example because let's take another simple, very simple example. The example is, right, this one. This is the example, right? We have this U1 u1, u2, u3, u4, right? We have here another graph which is like this, right? So we have v1, v2, v3, v4, and this is your g1 and this is your g2, and this says that if they are identify that if they are isomorphic to each other or not. Okay, isomorphic to each other, isomorphic to each other. Isomorphic to each other. So to prove that, what we have to do, firstly check whether the number of edges or number of vertices. So number of edges in G1 is 4, right? 1 2 3 4 edges, and number of edges in let's say in G2, 1 2 3 and 4 edges. Number of vertices in G1, which is vertices are 4, 1 v1 v2 v3 v4. Number of edges is also in G2, no? Which is 4, right? And then calculate the degree. So degree of u1 in this graph is 2, number of degree is in u2 is 2, the degree of vertex u3 is 2, and if you don't know about the degree, then find out my first lecture, right? So degree of u4 is your 2. So all the vertices are the same degree in G1, right? 2 2 2. And for v1, for this what to say about this graph G2, the degree of v1 is 2, degree of v2 is 2, right? Then degree of v3 is, it is 2, degree of v4 is 2. And the last is the adjacent vertices are of the same degree, right? So here we can see the adjacent degrees. If I say this adjacent degree, right? So these are the same thing. So we can say that these two graphs are isomorphic because this is your first condition, number of edges, number of vertex, right? So here I have written number of vertices, right? Number of vertices. In G1 is 4, edges is 4, in G2 we have vertices 4, edges 4, and the degree are the same, okay? So we can say that the G1 and G2 are isomorphic. Right. We have many examples when the two graphs are not isomorphic. So let me take another example. When we have to prove that these two graphs are isomorphic or not, right? So this is your example, right, in which we can say that these two graphs are not isomorphic to each other, and there are various examples basically, but I take this example to you, which is like this. So let me add another page here, right? Okay, now we have this this graph actually. The graph is your this is your graph, right? So we have this A, B, E, C, D, like that. Okay, and we have, this is your A's, this is your A's. Okay, and we have these edges. Then we have this another graph, which is this, right? So we have 1, 2, 3, 4, 5, right? So these are the two graphs, right? Okay, now let's find the number of vertices in this graph is 5, number of vertices in this graph is 5, number of edges in this graph. In this graph, the edges is 1, 2, 3, 4, okay, 5, 6, right? Edges in this 1, 2, 3, 4, 5, 6, okay. Edges, edges are 7 actually, because here you can see 1, okay, 1, 2, 3, 4, 5, 6 and 7, right? So number of edges are 7. So we have this 7 edges here, 7 edges here, and the degree, let me count the degree. For A, its degree is 3, 1, 2, 3. For B, we have degree 4. For C, we have degree, right, 3. For D, we have degree 1. For E, we have degree 3. And for this graph, for degree 1, we have 2. Degree of 1 is 2. Degree of 2 is your 3. Degree of 3 is 3, right? Degree of 4 is your 2, and degree of 5 is your 4, right? So let's take close look that we have in this graph G1, right? In G1 we have this type of degrees, right, which is your 3, 4, 3, 1, 3, and in G2 we have these degree 2, 3, 3, 2, 4. So we have 3, right, 3 vertices whose degrees are 3, but in G2 we have only 2 vertices having degree 2. So that's why these two graphs, right, G1 and G2, are not isomorphic. G and G2 are not isomorphic. Right? So okay, so that's it for this lecture, and I will come up with some more topics today itself, right? So let me know if there are any confusion or any doubts in these concepts from your side. Thank you. Thanks for watching.